Good morning dear students. Today we are continuing with nuclear physics. So let us first see what do we mean by the nuclear reaction. So let us see what is the nuclear reaction. So nuclear reaction is caused due to the bombardment of nucleus with a high speed energetic particle, that is because the nucleus has been bombarded with the high speed energetic particle like alpha particles. So what do we get? So we get the product nucleus as well as the daughter nucleus, and we also get some amount of energy. So these are the three things we are getting over here. So these are the product nucleus, the daughter nucleus, as well as some amount of energy that is we are getting it. After that, when we see that what is the difference between the rest mass energy of the nucleus and the force after the reaction, so that is Q. Whatever we have got in this nuclear energy that we are seeing in that last one, this one is what we are getting. So it is the difference between the rest mass energy nucleus before and after the reaction. So whatever was the rest mass before and after, it is the same. Now what do we mean by the nuclear energy? So nuclear energy is the amount of energy that is released during the nuclear reaction. So nuclear energy is that energy which is released during the nuclear reaction. So that will be our nuclear energy. After that, if we see that what are the types of the nuclear reaction, so there are two types. Now what are they? So first one that we see over here is nuclear fission, and the second one that we see is the nuclear fusion. So nuclear fission is our first one and the nuclear fusion is our second one. Now when we talk about the nuclear fission, let us talk about what do we mean by nuclear fission also. So when we talk about this nuclear fission, we mean that the heavy nucleus has been split to form the lighter nuclei. For example, we have the uranium isotope, which has the atomic mass of 235 and the atomic number of 92. Now when this is bombarded with one of the neutrons, what do we get? So we get one nucleus of barium, one nucleus of krypton, and 3 neutrons plus energy. So this is the nuclear fission, where we have the uranium nucleus isotope, and this when we have with the neutron we have barium, krypton, and then we got the 3 neutrons. Now when we talk about the nuclear chain reaction, so this is the here the reactant is produced again, which can further initiate the nuclear reaction. So in the nuclear chain reaction, basically what is there when the nuclear reaction is taking place, we can say that the reactant is produced, and this reactant which is produced is now further initiating, because this reactant first gets converted into the product, and when it gets converted into the product, this product is again changing into reactant. So that is the main how we are getting our answer. So here in this nuclear chain reaction, we have further two types. That is, first is if we have the controlled reaction, and the second one is that we have the uncontrolled reaction. So now these are the two types of there. If we talk about the controlled reaction, means controlled reactions are basically under the control, means we can control them. So these are those types of controlled reactions, and where no such harm is taking place. But when you talk about the uncontrolled reaction, so here the vast and the invisible amount of nuclear energy is released. Now if we have to carry out this controlled reaction, so how will be carrying out this controlled reaction? To carry out this controlled reaction, what do we need? So we need a nuclear reactor. This nuclear reactor will help us to carry out the controlled nuclear reaction. Now how is it going to help us? So first of all, if you see over here, so there will be the fuel which we will be having. Now this fuel can be any nucleus. Now what type of nucleus? We can have the uranium nucleus, we can have the another uranium isotope nucleus, and the third one is that we can have the another type of nucleus that we have seen over here. So these are the three types of the nucleus that we can have, and we can basically use them. The third one is the plutonium, which we can use. So these are the three types of nucleus which are fissionable. Means what do we mean by fissionable? Means they can undergo the fission. These can undergo the fission. So these are the fissionables. Now when we talk about what is a moderator, so moderator can be heavy water. Now what do you mean by heavy water? You know, D2O, that is deuterium oxide, or we can also have the graphite, or we can have the beryllium oxide. So these are the moderator. When we talk about the coolant, Now what is the meaning of coolant? So coolant is the one which removes the energy or the heat energy that has been generated. These are of three types. First is cold water, second is liquid oxygen. So these are both which are removing the heat generated. Now the fourth is the control rods. Now what are the control rods? It can be of cadmium, it can be of boron also. These rods help to absorb the neutrons. Means whatever are the neutrons produced, they are absorbed by these control rods. If you are not installing it, so you know that as the neutrons are produced, these neutrons further on, when these will be taking part in the reaction as reactants, they will again produce the neutrons. These neutrons will now increase in number, and now as they are increasing in number, so we are supplying the more reactants, and this way this will become the uncontrolled reaction. So we do not want that. So what do? We use control rods which are made out of cadmium and boron. So these are the three types of control rods that we have. Now let us talk about the next part, that is the atom bomb. Now what is atom bomb? We know. So the main thing that we have to learn is that it is also based on the uncontrolled chain reaction principle. Means over here also we say that when we talk about the moderator, so here we have no moderator, here also we have no control rods. So if the control rods as well as the moderators are absent, so what do we say? That the nuclear reaction will not be controlled, and that is we have the uncontrolled chain reaction. So this atom bomb is based on this principle only. Now let us talk about the next important one, that is the nuclear fusion. Now what do we mean by the nuclear fusion? So let us see it. So here there is one example. So I am giving you, this is an example. This is not the definition which you see. Example is that if we take the three deuterons, when we combine them, you know the deuteron is the heavy isotope of hydrogen. The three deuteron nuclei. So you can see over here, what is the difference between hydrogen and deuteron? The main difference is of their mass number. You know the deuteron mass number is 2, but hydrogen mass number is 1. Now what do we get? When we combine these three, means we fuse them indirectly, we get 2.16 mega electrovolt energy. Now what do you mean by electrovolt? You know that 1 electrovolt is equals to 1.6 into 10 to the power minus 19 of joule, and here mega electrovolt, so 1.6 multiplied by 10 to the power minus 19 multiply by 10 to the power 6 joule. So here 2.16 mega electrovolt energy you are getting. And what nucleus is formed? So helium nucleus is formed. The mass number of helium is 4 and the atomic number is 2. So this is being formed. Now what is the temperature used over here? It is 10 to the power 7 Kelvin, and the pressure that is used is 10 to the power 6 atmosphere. So these are the pressures which we are using it for the nuclear fusion. And the natural source is sun. Sun is the natural source of the nuclear fusion, where you can see that the deuterons or any other type of nucleus are combining, and there they are releasing the energy. Now you should also know that this energy, which is 2.16 into 2.16 mega electrovolt energy, is the enormous energy. This is the enormous energy, means this energy can supply, this energy is very huge in amount. So for 3 deuterons we are getting this much energy. Now you can imagine that how much such nucleus are present on the sun. So you can know that how much energy is released over there. So that's all for today. Thank you.